So let me get my glasses on and then we'll dive into 2.5, making my point, talking about the interpretation for equations that model linear. So linear, recall, linear could look like a straight line. It could also take on the form of y equals mx plus b. And also talking about exponential functions that may have more of an arch to it and has an a term, which is the initial value. So the starting value, if you will. The b term, which I usually like to put in parentheses, which is representing the, well, do you know? Do you remember what the b term is? Hopefully you're saying the constant change factor. Sometimes we think of this as the percentage that an amount of money keeps increasing by or decreasing by, and then we have our variable of x for an exponent. So we're interpreting the equations that model these two types of functions. Now, so this should all sound familiar. We're really just looking at them again. Does that sound okay with you? Are you having a good day? I hope you are. Zach, this name I don't know how to pronounce. If you know how to pronounce this, let me know. Zach and Sion were working on predicting the number of quilt blocks in this pattern. When they compared their results, they had an interesting discussion. Ooh, I like interesting discussions. Let me highlight that. It's just so interesting, I have to highlight it. Zach is saying, I got, this is me in my Zach voice, I got y equals 6n plus 1 because I noticed that 6 blocks were adding each time, so that the pattern must have started with 1 block at n equals 0. Okay, I would agree. It looks as if we're starting with that 1 block right here, and 6 blocks are added each time. So that's represented with 6n. 6 blocks added each time. 6 times n makes sense. Okay, Zach's onto something there. Then we got Sion. I got y equals 6 parentheses n minus 1 plus 7 because I noticed that at n equals 1, maybe we'll throw that in. This is where n equals 1. There were 7 blocks. Let's count them. 1, 2, 3, 4, 5, 6, 7. That's right. And at n equals 2, there were 13. All right. So this second term. So I used my table to see that I could get the number of blocks by taking 1 less than n, multiplying by 6 because there's 6 new blocks in each figure, and then adding 7 because that's how many blocks in the first figure. Okay, interesting. So we're representing these 7 as the original 7, which I would agree. They're built in over here. And then they're saying that every time it moves forward, 6 new blocks in each figure. Is that right? Am I missing something? 1, 2, 3, 4, 5. 1. Yeah, they're adding 6. Okay, so I'll mark up the new 6. I think that's important to note where your new 6 are. So there's 1, 2, 3, 4, 5, 6. Okay, so we have 7 in green, we're adding 6 in red, and they're saying that we're multiplying the 6 because there's 6 new. I could get the number of blocks by taking 1 less than n, multiplying by 6, okay? So they're starting with the 7, and then it looks as if they're breaking down 7 plus 6, and there's only one version of it. So it makes sense that they're chopping down this n term minus 1, and then multiplying that by 6. So here, this is 7 plus 6 times 2. Eventually, that keeps snowballing. All right. Both seem to be making sense to me. What else could be asked of us? I don't know. What do you think about the strategies that Zach and Sion used? I don't know. What do you think about them? Let's say that both are correct. Getting the starting points and measuring the changes. Are either of them correct? Yeah, I think they're both correct. Why or why not? Well, what was Zach's setup? I think he went back to the starting point, which would just be 1. So what did Zach say? Zach said it was 6x plus 1. Sion said 6 times x minus 1 plus 7. Well, let's think. We have both of these equations. One for Zach, one for Sion. This is a 6, believe it or not. I think that these are equivalent because if I distributed 6 to these two terms, this would get us 6x minus 6 plus 7. Red is an aggravating color to write with, so I'll switch to blue. Negative 6 plus 7, I can just rewrite that to positive 1. Boom, they're equivalent. Lo and behold. That's one interpretation with the equation. Suppose you could compare the tables if you set up one for Zach, because it would look awfully similar. So Zach's table could have looked something like this. At the 0 term, there's just 1. At the first term, there's 7. Second term, there's 13. Eventually, the tables are going to look the same. All right. Seems all right to me. You could graph these out. I'll do just that. 6x plus 1 would be starting at 1, and then it keeps adding on 6 every time. So that means that it's going to go to here, because remember at the first term, there's 7. So I think that's pretty interesting. Oh, gross. I don't want that. Let me redo that, make this a better line. So Zach's line, I'm going to draw in blue. Hope you don't mind. Zach's line looks like that. In pink, I'll draw Sion's. I mean, it's kind of the same thing, because when you rewrite it, they're going to be mapped out on the same line. Can't really see it all that well, but it's there. Maybe I'll make it thicker. Yeah, trust me, it's the same line. If you're not convinced, look at the equations, check the tables. They're both legit. That's just asking you to describe it, I think. All right, so they're both right. I'm with it. Let's see here. Looking at this problem, being asked to write the equation of the line shown on the graph below. When they were finished, here's the conversation they had and how they got their equations. Sion said, it was hard for me to tell where the graph crossed the y-axis, so I found 2 points I could read easily, which would be -9, 2. I'll map those out so we can see them. So -9, 2. Probably be right here. Yeah, it's definitely right there. So when I talk about Sion's work, I'll use pink. And then -15, 5, which was right here. Okay, figured out the slope was -1/2. They probably did something like this. They did rise over run, hopping over 1, 2, 3, 4, 5, 6. So having a run of +6. Rise of -2. Sorry, is that 3? No, it's 3, sorry. So eventually if you do rise over run, you get -3/6, which is really just -1/2. So I would agree with that slope there. And then made a table, checked it against the graph, and I guess they were saying that they were right. So it looks as if every 2 increments, we go down 1. So look, every 2 increments, we go down 1 in the f of x value. So eventually saying that they're starting at, okay, so they just kept snowballing it up to this +2. So this kind of looks interesting. Let's break this down. So they're saying that their starting point was this +2, which they found here. And they're eventually using this x term, but the opposite when they're talking about this, because this is 9 versions away from the previous term. Okay, so when you see this n plus 9, this is really saying that it's 9 spots away from n, which makes sense because it's -9 for x. It's not 0. Normally, our starting point means a big deal, but in this case, they're saying, you know what, I'm just going to start at 2. Maybe I don't feel like going the rest of the way. And that's the -9 term. And I know that every time I keep going to the right, I keep multiplying it by a half. Or sorry, subtracting one, sorry. Don't actually write down a half, you're subtracting 1. All right, seems like interesting work. I'm with it. And I guess they probably measured the slope this way too. This is another way, because they kept adding 2 to the x value, but deducting 1 in the y value. It's okay, that works. All right, what else? So they got that equation, shout out to them, very cool. I think I did something similar, but I used the points 7, -6, and 9, -7, getting that situation. All right, interesting. So they used some other points that were positive. So Zach, which I'll denote in blue, used 7, -6, should be right around here. 7, -6, 9, -7. Okay, so still getting that slope of -1/2 for the slope. So I would agree with this. And I guess, what else did they do? They referenced 9, -7. One of us must be wrong because yours says that you add 9 to n and mine says that you subtract 9. How can we both be right? Well, let's think. They are both using the same slope of -1/2, so I would agree with that. As far as how they're intertwining the 9 and the -7, it looks as if they're breaking apart, like they're referencing how this is 9 units away. So again, the point that they're referencing here, the one that I think they're shedding light on, is this 9, -7. And that's why in here, we have x minus 9 because it's, well, let me color coordinate this a little bit more. They're referencing this x value, which is 9 units away from where we usually start. So that's why in here, we're subtracting 9 because if we deducted 9, that would take us back to the origin. And then the y value right here, they're just throwing at the end. So think about this. This is saying that we are 9 units away from f of 0. So if we deducted 9 units, that would get us to -7. And if you're not too sure why this works, try to plug in 9 for x and see where that takes you. So as far as if one of them's right, one of them's wrong, I would say that they're both right. This is, I mean, Sion's kind of doing the same thing where -9 is kind of intertwined here because it's 9 units away, just in the opposite direction. And then this 2 is thrown in at the end because it's got to be there. So I would say both of them are right. What do you say? Can they both be right? Show some mathematical work to support your thinking. I think the easiest way to see that these two are correct with their equations would be to distribute. That would get you -1/2 x minus 9/2 plus 2. Uh-oh. All right, sorry. -1/2 x minus 9/2 plus 2 which is really just negative 1/2 x minus 5/2. Is that going to be the same thing here? Let's try it. This would be negative 1/2 x plus 9/2 minus 7, whole number 7. Eventually, you can rewrite this as negative 1/2 x plus 9/2. If you want to cross multiply, you'd be subtracting 14/2. Taking this further, getting you negative 1/2 x minus 5/2. Because 9 minus 4 gets you a negative 5. That's all over 2. So notice, same equation, which is fine. Yeah, they're right. So same equation. Mathematical work to support your thinking. It's right there. What do you say? They're both right. I would say that they're referencing two different points, but they're on the same line. Hopefully that makes sense how, again, the x and y terms that they're referencing, what they're doing right here. Like, again, they're saying that this is 9 units away from x, and the y value is just thrown in at the end. I think that's a big deal. It's actually really interesting how they're coming across that. We could graph them out if we wanted to, but I'll leave that up to you. Zach, my equation made me wonder if there was something special about the 9, -7, since it seemed to appear in my equation. When I looked at the number pattern, now I'm noticing something interesting. The same thing seems to happen with your equation. And the point -9, 2, describe the pattern that Zach is noticing. Similar to the previous slide, we're saying that really they're taking this value for x, they're putting it in here in parentheses because they're claiming it's 9 units away from normally f of 0, where we like to start. And then they're throwing in the y coordinate right after it, after parentheses has been acknowledged with the slope. And you can kind of see the same thing here because 2 is thrown in at the end. And then that -9, if you're not too sure what I'm doing, color coordinate, I think that helps. -9 is thrown in here, but again, it's opposites. So I think that's what's being mentioned here. Find another point on the given line above and write the equation that would come from Zach's pattern. Scratch pads given at the bottom. If you need a space to work out the problem, what would the pattern look like with the point AB if you knew that the slope of the line was M? Okay, let me see. Find another point on the line given above. Write the equation that would come from Zach's pattern. So Zach's pattern is using this. I guess we could reference the -9, 2. I think that could work. So what I'm going to do is I'm going to take this equation and I'm going to plug in this point. And this will be the work for number 4. So I'm using -9, 2 in Zach's equation. All right, so -1/2. Now it's x minus -9, and then -7. And then what do you think all of this is going to have to equal? I wrote that wrong. All right, instead of x, I'm putting -9. Good eye if you saw it. And then I'm subtracting 9. And then I'm deducting 7. And then what do you think this should equal? Again, we're claiming if x equals -9, what do you think the outcome is going to be? Hopefully you're saying 2. Let's try it. We'll focus first inside parentheses. So I'm focusing in right here. -9 minus 9 is just going to get me -18. That's multiplying with -1/2. Eventually we'll deduct 7. -1/2 times -18 is 9. 9 minus 7. Again, we're saying it should equal 2, which is the case. So we did just that. We found another point on the line given above. We wrote the equation that would come from Zach's pattern. There you go. So this was saying that if x was -9, the outcome is that y equals 2. Hope that's okay that I referenced this point. You could have used any x value though and found the y value. What would the pattern look like with the point AB if you knew that the slope of the line was m? Well, I'm really just going to rewrite this using those variables. So this would say that y is equal to, our slope, again, was -1/2. We then hit x. We're then subtracting a, and then we're adding on b. That's kind of how that sequence was going. So this is a really common way of graphing that we're going to be using moving forward, and we call this point slope. So take a note of this, write it down. We're going to need it moving forward. Point slope form, there it is. Did I skip something? No, that's it. Good. Okay, so point slope form, it's now in your toolbox. All right, Zach challenges you to use the pattern. He noticed to write the equation of the line that has a slope of 3 and contains the point 2, -1. Show a way to see if your equation is correct, okay? So I'm just gonna rewrite what point slope form looks like. I know that it's y equals mx minus a plus b, where this is our x term, which I'll call x of 1. And this is our y term, which I'll call y of 1. So this is claiming our slope is 3. And then we hit x in parentheses. We're then subtracting 2. And then we're adding on -1. But that seems kind of goofy, right, to leave that. So let's clean it up. Let's make it y equals 3x minus 2 minus 1, because when we add negative numbers, we can treat it like subtraction. Okay. Here's our answer. I guess if we're not convinced, show a way to see if the equation's correct. We could graph this out. And if we hit that point, 2, -1, and we're claiming that our slope is 3, we can do something like this. And our straight line should go and hit all these points. And the slope, well, yeah, I guess if you want it to keep going backwards again too, that's fine. But as far as seeing if this is correct, you could distribute. This gets you 3x minus 6 minus 1, which eventually can be rewritten to 3x minus 7. Does this type of equation look familiar? Hopefully you're saying yes, it's linear. And if we kept this going down, this should hit our y-intercept of 7. Should, -7 rather. Okay, 1, 2, 3, 4, 5, 6, 7. Yeah, it's hitting here. All right, so that's another way you can check your work, graphing it. It's a long video. You're still with us? Christopher Nolan wishes he could make movies this long. Christopher Nolan made the Batman series, if you're familiar with that. So Yoon challenges you to write the pattern to write the equation of the line graph below using the point 54. All right, so we have our point. What are we missing if we're going to write out this type of equation in this type of form? Point slope form. Hopefully you're saying that we're missing our slope. So far we can write in y equals, leave a little space for the slope. You can then write x minus 5 and plus 4. All right, let's see if we can find another point that's on this line. We could reference this one or this one. So it looks as if every 3 units, we get a new point that's easy to read. That's nice. Okay, so I'll map from 2, 3 to 5, 4. Okay, so this is going up 1 unit. So our rise is +1. And then our run 1, 2, 3. Okay. Is, yeah, that's our run, 3. So our slope is 1/3. So this should be y equals 1/3 parentheses x minus 5 parentheses plus 4. Boom. Take that, Sion. All right, I'll bet you can't use the pattern to write the equation of the line through the points 1, -3 and 3, -5. Try it. I bet I can. Can't stop me. Well, we have those points, so I guess you could reference either one. So what I'm going to do is I'm going to use this as my A and B. And that might be a good strategy. Label this x coordinate as A, this is B. You know that we're always writing in the form y equals m x minus A plus B. Again, a new way to write our equations, which I think is helpful. So what am I going to change here? Leave a blank for the slope. Put in A is 3. I know this is going to be adding -5, so I'm just going to switch it to -5. All right, so our slope. I know that if I were to get a table with those 2 points, I could do it. So I'll do that. So what I'm doing here is making a table to get the slope. So 1, -3, 3, -5. Our change in x is 2. So we'll put that in our denominator. Our change in y is subtracting 2. So -2 over 2. Factor formerly known as -1, that's our slope. So -1 is our slope. That works for me. So this answer here is all good. Show a way to see if the equation is correct. We could plug in 1, -3, and I'll do that. So this is using if x is 1, and we plug in, the outcome should be -3. -1 times 1 is -1. -1 times -3 is +3. Subtracting 5. From left to right, -1 plus 3 is going to be 2. 2 minus 5 gets us -3. -3 does in fact equal -3. So that's a good way to check your work. So this was considered a check. Hope that helps. Geez, what a section. There's so much good stuff here. Wonder if we could use this pattern to graph lines, thinking of the starting point and using the slope. Try it with the equation. All right, so what's our starting point? We should be saying, in this case, it's the opposite of this term, opposite. So that's a huge TL. It's the opposite of this number here, and that's our x coordinate. So the opposite of +1, in this case, is just going to be -1. And then our y coordinate, in this case, is -3. Our slope in front of the parentheses should be -2. And then we can graph this out. Okay, so starting at -1, -3, our slope is 2. So -1, -3. Our slope is 2, so it's going over 1, up 2, over 1, up 2, over 1, up 2. That should be sufficient. Okay, is that it? Is that all that was asked of us? Try it with the equation. Do I have to submit this? No, but it would hit those points. That's right. Zach wonders, what is it about lines that make this work? How would you answer, Zach? We have infinitely many points on the line. No matter which 2 we use, they should contain the same slope / steepness between them. Could you use this pattern to write the equation of any linear function? Well, Well, I think the only option that might be a little hairy is if you have a slope that's undefined. And this occurs if you have 0 in your denominator. And this is like some number, but this eventually wouldn't work too well, I don't think, because then this is saying that your slope's undefined. And if your slope's undefined, you can't really write anything else legible after it. So I'm going to say no. Reason being, if we have an undefined line. That's my guess. Some equations that I think are helpful. This is kind of a recap. So slope formula, we can still use that if we want to between 2 points. You saw that what I did personally was set up the table and then get the change in y, the change in x. I'll do that one time here. So change in y, 3 to 7 is just adding 4. 1 to 4 is just adding 3. So you could also just say that this is change in y is 4, change in x is 3. So your total rate of change or slope is 4/3. We always prefer y equals mx plus b because I think it's just installed in us in middle school that that's what we like. But be open now to point slope form. It totally makes sense how it's put together. Think about what I was mentioning in Zach and Sion's example, how it's just 9 units away or 7 units away. It's okay if that happens, but be open to that other interpretation. All good. All right. If you have any questions, please reach out, talk to your teacher if this is for a different class. Thank you so much for watching. I hope you have a wonderful day.